Antiderivative and definite intervals. The objective, write the general solution of a differential equation and use indefinite interval notation for antiderivatives. I will explain all this, okay? Just listen for the objective for now. Use basic integration rules to find antiderivatives and find particular solution of a differential equations. Antiderivative. Does everybody see that? We did derivative, chapter 1 through what? 3. Now we're going to do what? Anti. What anti means? Opposite. Are you with me, class? Just like what it says. All right, to find a function f whose derivative is 3x squared. You might use your knowledge of derivative to conclude that f of x is equal to what? X to the third. Are you with me, class? I'm saying f of x is x to the third because if you take a derivative of this, what do you get? 3x squared. Am I right, class?
Right.
Does everybody see that? So we're thinking backward. I want to look for function f. Function f, the big F, means antiderivative. Are you with me, class? This means antiderivative. We usually use big F stand for antiderivative. Okay, the small f is what? We usually use a small f for what? Just regular function. If I want to go back, I just use big F. Just so you know, I'm looking for antiderivative. All right, so function f is antiderivative of small f. So this is your definition. Definition of antiderivative. A function f is antiderivative of small f on an interval I when f prime of x is equal to what? F of x. Or all x in I. So this is the same thing. So if you take a derivative of this, what do you get? 3x squared, isn't it? Are you with me, class? So if I want to go back this way, then you get which one? That one. Are you with me, class? All right. So note that f, the big F, is called an antiderivative of small f rather than the antiderivative of f. To see why, observe that f1 of x. I'm just giving you a particular example. First f, x to the third. I'm going to give you another example. F of 2 of x is x to the third minus 5. Next one is f of third is this. Well, let's take a derivative. What's the derivative of this? 3x squared. What is the derivative of this? Again, 3x squared. Am I right?
Yep, 3x
What's
squared.
this one?
3x squared.
Again, 3x squared. So in other words, if I go back, if I decide to go back this way, would I know which one to go? No. Am I right? Because this can give you this. This can also give you this. Because a constant, when you take a derivative of a constant, what do you get? Zero. So that's why you have to put constant C. Because you don't know. When you take antiderivative, you don't know how to go back. Which one? Either this or this or this or other one. Who knows what constant that is? Is everybody with me? So that's why when you take antiderivative, you make sure you put what? The derivative plus what? C. That C means, in this case, what's my C? 0. What is my this case? Negative 5. What's my C in this case? 97. So I don't know which C to put it in. Are you with me? So just put plus C for now. So in case there's any number, then I can put that number there. Is everybody with me where the C came from? The C is ensuring some constant you may have. Because when you take a derivative of a constant, give you what? 0. All right. So you call it, this is what? Family of all antiderivative of what? 2x. So if I give you derivative of x squared, what do you get? 2x. We know that, right? But if I go back, you get what? X squared, right? But I don't know. It's x squared plus 1 or x squared plus 0 or x squared plus 97. I have no idea. So I need to put what? X squared plus which one? C. The C will cover any constants you may have. It could be 0, it could be 97, it could be 1,000, whatever the constant that is. So you need to, whenever you take antiderivative, you need to do what? You do antiderivative plus what? C. Always put the C. That will cover any constants it may be there. All right? So the constant C is called what? Constant of integration. All right. So if I give you this, I want to find general solution of differential equation. To begin, you need to write a function whose derivative is 2. Which one gives you 2 as your derivative? 2x, right? Are you with me? Because if I have derivative gives you what? 2, right? But I also can have which one? Remember, you have many different ones you can choose. Can I have this? Can I have that? Does it give you also 2? Right. So I need to make sure to put what? 2x plus what then? C. That's right. So you're going to do that. The function is 2x, but that is a particular answer. But I need to make sure it covers everything. So what do I need to put? 2x plus what? C. Is everybody with me where the C came from? Okay. All right. So in other words, I can have so many different ones. 2x plus -1, or 2x plus 2. All of this is what? Antiderivative of 2. So are you following me, class? All this is antiderivative of 2. This is all family of antiderivative of 2. All right, so now we're going to use a new variable. So you see this sign right here? That's an integral sign. Right, this integral sign is antiderivative. So the general solution is denoted by antiderivative, okay? You write y is equal to integral, all right? And then your function and dx, and you will write down your answer. The answer gives you big F of x plus c. So you can rewrite like this. The problem we just did. That's how you write it. And you're going to say, what? What's my answer then? My answer is what? 2x plus what? C. So this sign right here, this long S, that is what? Antiderivative. Well, you can also say integral. Is everybody with me? So I can write it like this. I'm looking for what is antiderivative of 2. I will get what? 2x. Which plus what? C. Because C will cover any constants you may have. All right, so this is a derivatives. You get a constant, you get a what? 0, right? So if I get a 0, you get a what? Constant. I have a kx, derivative of kx give you what? K. So if I have integral of k, what do you get? Kx plus what? C. Does everybody see that? They're corresponding to each other. K f of x is a k times what? F prime of x. So that's what you have. I can put the k in the front, take an integral of f of x. I have a plus and minus. I can do what? Derivatives, add derivative and subtract derivative. I can do that, right? Same thing for, I can do integral, antiderivative addition, antiderivative subtractions. I can do that. I can do everything pretty much the same thing. There's a power rule. Look at this power rule. This is the one you're going to use the most. So power rule, what did you do? You put the power in the front, and you get a what? One less power. Am I right, class? Look carefully this one. So if I have this, look at this. Remember, antiderivative means the opposite. You used to do what? You are subtracting. Now what am I doing? Adding. You used to multiply n. You're going to divide it by what? N plus 1. Remember, you got this power is n plus 1. So you divide it by n plus 1. All right, let's just look at the one problem. Is everybody with me? I'm doing a power rule, anti-power rule. Is everybody with me? It says what? Add one more power. 3. Am I right? And what else does it say? Divided by what? Divided by the power. And then what do you do? C. Then you're done. Is everybody with me? So you're doing a power rule, but you're doing a what? Anti-power rule. So power rule usually do what? You multiply by your power and one less power. But now antiderivative, what do you do? You add one more power and then what? Divide by one more power. Does it make sense to you? So if you can do derivative, antiderivative is also easy because this is what? Just opposite of what you've been doing. You're just doing opposite. All right, so same thing. Derivative of a sine is a cosine. So what is the antiderivative of a cosine then? Sine, right? Because you're doing opposite. You have a derivative of cosine is what? Negative sine. So what is the antiderivative of a sine? Negative cosine, because derivative of a cosine gives you negative, but I'm doing an antiderivative of a sine, so I need to have a what? Negative cosine. So class, you need to memorize this, okay? This one is better to memorize and trying to figuring out. You're supposed to memorize this. Are you with me, class? So you can do your homework problems. All right, let's do this. What is it? Try to do it right now, class. So 3 is nothing. Just leave 3 in the front, right?
Right.
Use the anti-power rule, right? Remember, you got one power. So I want you to see. Go ahead and do it. I'm not going to do it right now. I want you to do first and then look at mine. Take antiderivative of this. What do I put it in here, class? All right, Ms. Johnson, what do I put it in here in my square box? 2. 2. Everybody agree?
Yes.
This is 1, adding 1 is what? 2, and I'll exactly put the same number where? In the denominator, right? 2. So my answer is what? 3 over 2 x squared plus c, because I want to put the 2 under the what? 3. So you look right? Coefficient in the front. Does it make sense to you, class?
Yes, right.
So antiderivative is not hard. Is everybody with me?
Yes.
Because if you know how to do derivative, antiderivative is just the opposite. All right. So we're going to do ordinary integrals, rewrite it, and integrate it, and simplify. So sometimes your problem is being maybe complicated. But this one is not that complicated, actually, right? You have 2 problems. You do this one first, and then what? Do that one. Let me see. I'm trying to see your homework problems. Okay. Look at this problem. That's what they mean by rewrite it. If you have a 1 over x squared, you know, if you have a problems like that, you cannot take antiderivative, right? You usually have to do what then? Rewrite this as what? Power rule. So I can use a power rule, right? Is everybody with me? All right, so if you do this, antiderivative says what? Negative 2 plus what? 1. And I'm going to do exactly what? Same thing in the denominator, which is what? Negative 2 plus 1. Am I right, class? So I'm not done yet. I'm going to simplify it a little more. That gives me then what? x to negative 1 over negative 1 plus c. So this is actually the same as what? Negative x to the negative 1 power plus c. Am I right, class? This negative in the denominator, I can just put in the front, right? But what does this mean? Negative 1 power means? Where do I put it? To make it right. So I have to put the bottom to make a positive power, right? That's my answer then. Let me quickly. That's what I mean by rewrite. When you do your homework problem, they're going to ask you to rewrite. Rewrite means if you have problems like this, you cannot take derivative or antiderivative. You need to rewrite this one as what? Power rule. So put this in a power. So right now it's the denominator, make it into a numerator power. And then you can do derivatives or antiderivatives, whichever you want to do.